Alright, pretty cool lesson today. We're looking at geometric sequences and we add those up to a geometric series. So right off the bat, let me just give you the formula, okay? So I'd encourage you to write this down, just keep it in front of you. So S sub n, again, series of so many terms. First term, remember R for geometric is the ratio, and of course n is the number of terms, okay? So let's look at an example. Use this formula, and you don't need to remember this, alright, just know how to use it. Use the formula to evaluate this series. So let's look at what we need to know. Well, I need the first term. There it is, okay? And I need R. Well, how do I go from 2 to negative 10 to 50? Let's see, looks like we're multiplying by negative 5, right? So R is negative 5. And then I need N. How many terms? Well, it tells me right here. I'm going 6. So let's write that. So S sub 6 equals 2 times 1 minus, and what are we doing? Negative 5 to the 6th all over 1 minus my R again, which is negative 5. So that would be plus, right, if we just change those signs. Okay. Now let's go plug this in a calculator. You can do it in any calculator. I'm going to go ahead and bring Desmos up on the screen just to show you how we could plug this in. So we've got 2 times, I'm going to use this fraction button just to make it easier to plug in here. So 1 minus negative 5 to the 6th power. So there's my top, right? Just double check here. And then 1 plus 5 down on the bottom, of course. And notice we get negative 5,208. So this series adds up to be negative 5208. Okay, just plug it in. Be careful, not too bad. Now, here's kind of an interesting idea. Sum of an infinite sequence. Well, how can an infinite sequence have a sum? It all depends on the R. Okay, if the common ratio is something in between negative 1 and 1, like 1/2, 1/3, something like that, then these series converge to a definite sum. Alright, so we use that word converge. They're going up toward a definite point. Because each time you add, right, if imagine my ratio is 1/2. Well, something times 1/2, times 1/2, times 1/2. You're getting smaller and smaller and smaller amounts that you're adding until ultimately you're just adding such a small amount it doesn't change the number we're approaching. So here's our formula. This is for infinite. And again, I'd encourage you to write this down. Notice, how's this similar? Well, there's no n because it's infinity. It's got the first term, got 1 minus r. That's very similar. Notice the other one had this, 1 minus r to the n. Well, why isn't this here? Man, again, imagine r is like 1/2. Well, 1/2 to a really big number is basically 0. So 1 minus 0, it just goes away. And that's why we get our first term over 1 minus r. So it's really a pretty slick relationship. What if we just want to identify, does this thing converge or diverge? Well, the key is, what's the ratio? So 1/3 to 2/9. How did I get from 1/3 to 2/9? Well, I multiplied by 2/3. 2/9 to 4/27, 2/3. Yeah, that would work, right? So my R is 2/3. Well, is that in between negative 1 and 1? Yes. So yes, this converges, all right? How about this one? 7 to 28. Well, my R is 4. Is this going to converge? No. Okay, so this one diverges. This one converges because this is just getting bigger and bigger and bigger numbers as we go. Let's evaluate an infinite series. Okay, again, here's this formula. You don't need to memorize it, but have it written down somewhere. What do we need to know? Well, we need the first term. Oh, it's 25. What's R? How did I get from 25 to 5? Well, I multiplied by 1/5, right? 5 divided by 25. And so, or I could do 0.2. So if I did 1 minus 0.2, this would be 25 over 0.8. Now we could plug that in a calculator really quick. Let me just bring my calculator back up. So 25 divided by 0.8, and we get 31.25. So notice we could do that pretty quickly. If I don't hold down my button here on my pen. So 31.25. So this converges to a value of 31.25. All right, how about this one? What we got here? Use the formula to evaluate the infinite series round to the nearest hundredth. Okay, so now they give us sigma notation. All right, so this is infinity. You can't see that symbol very good, but it's infinity. Let's use the formula. Okay, what's the first term? Well, if I plug a 1 in here, 1 minus 1 is 0. 1/4 to the 0 is 1. 3 times 1. So my first term is 3. So first term is 3. Now 1 minus, well I need r. Hey, r's right here, right? This 1/4 is my ratio. So 1 minus 1/4. 1/4, by the way, actually let me do it this way. So 1 minus 1/4 would be 3/4. So 3 times 4 over 3. So this thing converges to a value of 4. So see how we can evaluate that pretty quickly? Okay, again, I know that's kind of quick, but I hope it gives you an overview. I hope you took some notes, and of course, come back to this video if you want to as you go through the lesson or as you get ready for the quiz. I think it'll help you out.